All right, this is 7.5, hypothesis testing for variance and standard deviation. So this is the last section for chapter 5. We'll review and then take a test after this section. Critical values for the chi-squared test. So we've already done z, then we did t, then we did p, so the last one we have is chi. So it seems very similar to chapter 6. We followed through each individual one. In real life, you need consistent and predictable results. For example, producing golf balls. Millions are produced and they need to all have the same size and the same shape. If the population is normal, then you can use the chi-square. So some steps. First, you're going to figure out the level of significance, your Jesus fish looking thing. Then you're going to solve for your degree of freedom, which is your number of items, your n minus 1. Then you're going to use the chi-squared chart, which is backed by the z and the t. For the right, you're going to use the value that goes with the degree of freedom and your Jesus fish. For the left, you're going to use the degree of freedom and 1 minus. And for the two-tailed, you're going to use the degree of freedom and 1/2 and 1 minus 1/2. So something to note is that these are opposite of what we've normally done. Usually the right is 1 minus, and the left you take as is, but in the chi-squared you're looking at the opposite, so be careful with that. So number 1, find the critical chi-square value for the right-tailed test when your n is 18 and your level of significance is 0.01. Okay, and it says it's right-tailed. So I'm going to start off by finding my degree of freedom, which would be 18 minus 1, or 17. Since it's a right-tailed and I'm looking at the chi, I have no change. So I'm going to look in the back of the book at my chi-square chart. I'm looking at 0.01 and 17. 33.409. And if they asked you to draw it out, look like this. It's a right-tailed test. Something like that. Okay, number 2 says find the chi-square value for a left-tailed test with an n of 30 and a level of significance of 0.05. Start out by finding your degree of freedom, which would be 30 minus 1, or 29. Okay, it's left-tailed, so I have to do 1 minus my level of significance because I'm looking at a chi-squared. So if I wanted to draw it out, I could. Left tail is over here. So now I'm going to look in the back of the book at 0.95 and 29 to find 17.708. Okay. Example 3. Find the chi-square values for a two-tailed test when your n is 51 and your level of significance is 0.01. Start out by finding your degree of freedom. 51 minus 1 is 50. And since I have a two-tailed test, I have to do 1/2, 0.01, and 1 minus 1/2, 0.01. So I know I'm looking for two values because it's two-tailed. So I'm going to have a left and a right. So if I look at 1/2, times 0.01, I'm looking at 0.005. And I'm looking at 50, 79.490. And now I'm going to look at 1 minus 1/2, which would be 0.995, and 50, which is 27.991. So again, this one is going with this one, this one's going with this one. It's also just greatest to least. The left is going to be the smaller one, and the right is going to be the bigger one. But they're also swapped, so the left has the 1 minus, and the right is just 1/2. Okay, so the chi-square test. Testing for variance, which would be here, or the standard deviation. The test stat is always s squared. The equations are on page 406 if you need to see them, but your chi squared is going to be n minus 1 times your s squared all over your standard deviation squared. And your degree of freedom is still n minus 1. So if we go through the steps, start out by stating h sub o and h sub a, identify your level of significance, your degree of freedom, find your critical values from the chi chart, determine the rejection region, which again, that's where it's shaded in, solve the chi-square test equation, and then reject or fail to reject. So this one says, a dairy processing company claims that the variance of the amount of fat in whole milk processed by the company is no more than 0.25. So I'm going to start by writing my h sub o and my h sub a. It's talking about variance, so I'm going to write my symbol for variance. I know h sub o can have equal to, and it says is no more than, but can be equal to, so that's going to be my claim. Okay, since my h sub a is pointing to the right, I know this is going to be a right-tailed test. Keep reading. It says you suspect that this is wrong and you find a random sample of 41. So my n is 41, which would mean my degree of freedom would be 41 minus 1, or 40. Has a variance of 0.27. Okay. So that's my sample variance. Okay. Level of significance is 0.05. Are you rejecting the company's claim? So first, let's draw out our picture so we can get our rejection region. I know it's right-tailed. Since it's right-tailed and I'm talking about chi, I'm going to have to do 1 minus 0.05. Oops. Nope. Not 1 minus, because it's right-tailed and it's chi. So if it was z, I would do 1 minus, but it's chi, so I don't. So I'm looking at 0.05 on my chart and 40. I find it to be 55.758. Okay, that's going to be my rejection region. So now I'm going to plug everything into my chi-squared equation, which is n minus 1, which I found to be 40, times my standard deviation squared, which they gave me my variance already, so I don't have to square it, divided by my population variance. So I'm going to plug that all in to find 43.2. So that's going to be over here. It's not in the rejection region. So I would fail to reject. Okay, and you could say not enough evidence at my level of significance was 0.05, so I could say at 5% to reject the claim. and just leave it at that. So you can always change this level of significance to a percentage to say that you can't at 5% or whatever that level of significance happens to be. Let's try another one. A company claims that the standard deviation of the length of time it takes an incoming telephone call to be transferred to the correct office is less than 1.4. So start out with your H sub O and your H sub A. We're talking about standard deviation, so I'll put the correct variable. I know this one can be equal to, and it says is less than, so that would be here. This is my claim. Opposite would be my H sub O. So I see it's pointing to the left, so this is going to be a left-tailed test. So again, chi-squared left tail is going to be my 1 minus. A random sample of 25, which means my degree of freedom is 24, has a standard deviation of 1.1. At a level of significance of 0.10, is there enough evidence to support the company's claim? So since it's left-tailed, I'm going to do 1 minus my level of significance. So I can find my rejection region. It's left-tailed. I'm looking at 0.9 and 24. $15.659. So now let's plug it into our equation. Chi-squared should be n minus 1 times the standard deviation squared, which they didn't give that to me, so I have to square it, all over, again, this has to be squared. In the last one, just for reference, they gave us this and this and this, which is why we didn't square anything in our equation. It was already squared for us. So I'm going to plug that in to find 14.816, which is right there. It is in the rejection region. So I would reject H sub O, and I could say at, in this case, it would be 10%. There is enough evidence to support the claim because I threw out H sub O. All right, let's try one more. A sporting goods manufacturer claims that the variance, so if I wanted to start out H sub O, H sub A, variance, so we're going back to the thing is already squared, is 15.9. So I see I have a two-tailed test. Okay, random sample of 15, which means my degree of freedom is 14. Has a variance of 21.8. And I'm looking at, level of significance of 0.05. Is there enough evidence to reject the manufacturer's claim? So since it's two-tailed, I have to do 1/2 0.05 and 1 minus 1/2. Whoops. Let's fix this. So 2 tails. So I'm going to look at 0.025 and 14. 26.119. Okay, and then 0.975 and 14, 5.629. Okay, plug everything into my chi-square equation. N minus 1 was 14. Everything is already squared in this equation, so I don't have to square. Plug it in to find 19.195. 19.195 is somewhere in the middle here, so it's not in the rejection region. So I would say fail to reject. And I could say at 5%, you can't reject the claim. And leave it at that. Okay, so your notes should be completely filled in for Chapter 7. I'm going to check those probably tomorrow. And we will also begin the 7.5 assignment tomorrow.